Fine. If anyone are having any doubts, ask me. Otherwise, we'll start the new topic, that is STP. STP stands for Spanning Tree Protocol. Okay. Before spanning tree, we'll discuss what is the requirement for spanning tree. Okay. In your campus, you have multiple different floors. It's first floor, you're having one switch, and in another floor having one more access switch, the other floor having one more switch. This switch is connected to one distribution switch. We'll discuss distribution switch later. First, these switches, it's like first floor of switch. Switch one is your first floor switch, and in your campus in different floors, that is second floor, you're having one more switch. These two switches connected to each other likewise. They both are connected. Likewise. Here, 20 users are there, 20 ports. And in first floor also, 20 ports, 20 hosts are there, 20 users. They both wants to communicate to each other, first floor to second floor. Like here we are having this user wants to communicate this user. There are users only, 20 ports like connected. Here we have 20 ports, and here we have 20 ports. Then they both are in one network only now. They both are in single network. This user wants to communicate this user, then they communicate to each other. It's, of course, the link is there. With this link, they can communicate to each other. Good, because they are in single network, like they are communicate to each other. Now, what happens if this link goes down? If this link goes down, what happens? They both can communicate or not. Link is not there. Then how they will communicate to each other? Anyone having any answer?
A router?
Through?
A router?
Throughput. It means a router. Okay, but I told you here the same network only, in a single network, a router is required or not? In a same network, they want to communicate. This is a single LAN. They need a router.
No.
No, not required. Good. Then
But
if link, yes, tell me.
we have like plan B, right? Every like network we keep like two routes.
Two
One is
routes. Good. You mean to say redundancy path, redundant path, right?
yeah.
Okay,
Yeah.
fine. Good. Fine. Like I'll move to the. We have one more path. One more path we have. They both are connected likewise. This link also working fine With the help of this link, we can communicate if this link goes down. If they both are connected likewise, two links are there. This link is first Ethernet 0 by 0, F0 by 0, and F1 by 0 something. Okay. And here F0 by 0 and F first Ethernet 1 by 0. Good. With these two links are there, what happen if they both are in same network? There we have a broadcast terms will be happen, and broadcast means switch what it will be do that whichever frames are there, it will be sent through this port as well as these ports, and once they receive, then they will receive the port or receive the frames, then they'll send again to this link. Whichever information switch got, it will be broadcast the information. Otherwise, we have one more connectivity. It's third floor. Switch 3 we have. This switch 3 again connected to this switch. This switch will again send to this switch also. Again. Then once they will receive, it will be broadcast the information. These all are broadcast forms will be happen. Then here they are sending and receiving, sending and receiving, sending and receiving. What we call it is a loop. It's a loop will be happen here. Understood? So we want to reduce this loop. We have a spanning tree protocol. Understood? What is the requirement for spanning tree? Again, I'm explaining. Whenever switch 1 wants to communicate this switch, the switch originates some traffic, some frames. That time switch 2 will receive the packet that frames, and this switch, if STP is not enabled, this switch again send to switch 3 as well as switch 1. If the port is not down, it will be received from this port also, this port also. It will be traffic like loop will be happen. So we want to reduce this loop. We have a spanning tree protocol. Let's assume how will reduce the loop. Here you have one switch and another switch. These two switches are connected to each other. Switch 1 and switch 2. They both are connected. So traffic will sending likewise and receiving also. Same ports. Both are up. So loop will be generated here. The packet, this end user is sending some, originating some traffic. He wants to communicate this PC to this PC. PC1 wants to communicate PC2. Likewise, as PC1. PC2. Then traffic will be, frames will be generated. It will be communicate to each other. Likewise, if the it will be send and receive. If one port, when if two paths are there, redundancy is there, that time the traffic will send and receive, sending this path and receiving this path, same switch. Here loop will be happen, loop will be generated. So in switch, in Cisco switches, by default STP will be enabled. By default STP will be enabled. By default STP will be enabled. With that STP, one port will be like blocking port. Once port will be blocked, then the data will be flow likewise, then receive likewise. Here we have two types. So if STP is not there, so we should have to manually we should have to shut down this port. If this port we did manually, means we are not at right time when this port is down, that time we are not available, then traffic won't originate her. Traffic will also not communicate to each other. So STP is there, then automatically if this port went down, automatically this port will be come up with the help of STP. If STP is not there, we should have to manually configure whichever port went down, then other port we should have to we use the command like no shutdown, then only it will be up. Understood?
Just a minute. If one port goes down, does it automatically activate the next port, or we need to do that manually? If STP is enabled.
See, good question. If again I'm explaining you, if STP is enabled here, okay, let's assume.
Sorry, Alim, like I have like a small doubt before explaining this STP.
Okay, fine. Okay.
Like, is it possible like loop only the two devices are there? Loop will occur like only two devices, because one it gonna send, because in the broadcast, what does it mean by broadcast? It gonna send except the sender switch, right? Like sender PC or anything. It gonna send to remaining things or like any message or anything. If the two devices are there, the loop gonna be occur, because
Yes.
it doesn't send right back.
It will be sent. It will be sent. Whichever the we have a two redundancy path, right? Here we have two redundancy path. Then it will be sent. If only one path is there, then no issue. If this path is went down, then here only we have one path. Here only we have a one path. Then this path went down. These two users can communicate to each other or not. Here no loop will be occur. Good. Here no loop will be occur because only one path is there. But this path is went down. Then what is the issue? They both communicate this PC to this PC.
No.
No. That is why we need a backup path, redundant path.
Yeah.
If
No, for the backup path only, the loop will occur, because one path is down, the other path will be sent, right? The message to the sender.
Yes, right. Whenever the STP is enabled, by default STP is enabled. Okay, that time one path automatically down. Behalf of some election criteria is there. We'll discuss root port, designated port, and root bridge also. Elected election will be happen. Then only whichever the root bridge is there, that switch only originated the traffic. Who and all required. We'll discuss. We'll discuss the thing later. And see, Ajay, whenever see here manually, if we are configured, manually is doing. That is our engineer manually is doing. Whenever the STP is not enabled in the switches, loop will be occurred. So we should have to shut down one port. Otherwise, both ports are enabled at a time. That time loop will be originated here. loop will be occurred here. Understood? If I want to
Yes, sir.
prevent that loop, we have a STP. It will be by default enabled. I hope you got your answer.
Okay.
Fine. See, if its two switches are connected point to point, that is fine. If we have three switches, here one more, three switches is there. They are connected likewise. Here redundant path is not there till two PCs are connected. They are originating some traffic. Then the data will be moved likewise. It will move likewise and will come likewise. There is not required for STP. There is not required for STP. Once this link went down, this user wants to communicate this user, then this link went down, then what happened? Again, same problem. The connectivity is not there in between these two switches. So we have a full mesh topology here. We should have to use full mesh topology. If this link went out also, no issue. With this port, we can communicate to each other. The data will be happen. The communication will be happen. Understood? But here also, in this full mesh topology, if ports are not one port automatically not down, then again loop will be happen. How? This switch originates some traffic. This switch originate some traffic. Then again this switch is come to here. Again broadcast happen. Switch what it will be do broadcast. Then again this switch receive this information. Again this switch will be send the information. Again this switch will be received. Again this switch will send the information. Loop will be like happen if STP is not enabled. So based on election criteria, one port will be automatically down. One port will be automatically down. STP required here. Understood? Okay, I'll give you some notes related to STP. Just write that notes. We'll discuss. Where it will originate the loops in layer 2. A layer 2 switch belongs to only one broadcast domain and will forward both broadcast and multicast out every port, but the originated port, whichever the originated port is there, that will be send broadcast and multicast traffic. This port will be sent to broadcast or multicast. When switches loop is introduced into the network, a distributive descriptive broadcast stream will be developed within a seconds. Within a second, the broadcast stream will be occurred here. A stream occur when broadcasts are endlessly forward through the loop. Eventually, the stream will choke off all other network traffic. Understood? It will be originating the traffic, what we discussed. The same thing here. Understood? How the election will be happen, we'll discuss now. Still, till now, anyone having any doubts?
No, sir. All good.
Good. With the help of election criteria, spanning tree protocol was developed to prevent the broadcast from caused by the switching loops. Okay, broadcast from is nothing but to loop. Switches running STP will build a map or topology of the entire switching network. STP will identify if there are any loop and then disable or block as many ports as necessary to eliminate all loops in the topology. See, if we have two connectivity, if that is possible, if we have multiple connectivities, redundancy purpose, if one port went down, then other ports will be happen. If here one port automatically down, whichever those ports will call it as a alternate or blocking ports. Alternate or blocking port we will call. STP switches exchange. The STP switches exchange BPDU information. Whichever we are originating some traffic, that those all are, we call it as a BPDU message. Like what it will be happening. BPDU contains information regarding port information, switches information, port priority, and IP addresses on that. Whichever addresses, those information will carry with the help of BPDU content, BPDU packets. What we call it as BPDU message. It's interview question. Whichever the information they are carrying, that we call it as a bridge protocol data unit. And bridge protocol data unit uses the MAC address, multicast MAC address. With the help of this MAC address, they will send and receive the information. With the help of BPDU. Bridge protocol data unit. Anyone having any questions?
All good.
Ajay?
All good, all good. Sir.
Good. Thank you for confirmation. See, I told you BPDU election will be happen. How to elect? The STP topology is a multi-step convergence process. There we have multi-step convergence will be happen. I'll give you one diagram here. Then for your easy understanding, before the labs, this is your switches are there. All are your switches. Likewise, here switch A, switch B, switch C, and switch D, switch E are there. One host is connected. Fine, it's our normal topology. Whenever we are using labs, with the help of this topology, I'll show you how it will be happen. And we'll the election, first of all, first it will be check the root bridge. Again, root bridge, whenever I say bridge, in the sense in a legacy network, in earlier what we call it as a switch is nothing but to bridge only. Earlier we call it as a bridge in the sense switch only. Nowadays we are calling as a switch, but earlier we call it the bridge only. That is the reason in STP still we are using bridge word. And root bridge in the sense master bridge, master switch. Whichever it will be showing the path. It is showing the path. A root bridge in the sense master switch. In our, if we have here 100 switches at your LAN side, 100 switches in your LAN topology, they all are connected to likewise in different floors. If you have 10 floors, in 10 floors, the connectivity full mesh likewise. In this, all the switches, only one root bridge is there, not more than that. In one LAN topology, only one root bridge, not more than that. Only one root bridge. Apart from that, all are the non-root bridges. Non-root bridges. Non-root bridges only. Any doubts?
No.
Good. Now move to the root port. What is the root port mean by? See, if here you have one switch, it's a root bridge, and this bridges is connected to each other. Likewise, it's a full mesh topology. It's a root bridge, and this ports, whichever ports, these all are the designated ports actually. The root bridge having only designated ports. Root bridge having only designated port. Now opposite to designated port, DP. Designated port means DP. Opposite to DP, we having a root port. Root port, and opposite to having, and root port receive the information. Root port will receive the BPDU information. It won't send. Okay, receive, and it will be implement here. Then whichever here one more designated port. Opposite to, in switch only one root port will be happen. In a switch only one port will be root port happen. If we have multiple ports also, only one root port will be happen. Opposite to root port, we have one DP designated port. Apart from that, one is blocking port. Block. That it will be blocking state. With the help of blocking state, we can eliminate the loops. Anyway, I have some PDF for that. I have content for that also. I'll give you how the election will be happen. How root port elect. How root bridge elect. Fine. Electing a root bridge. The root bridge serves as the central reference point for the STP topology. I have mentioned only one root bridge available in your LAN. STP is enabled by default on all Cisco switches. STP by default, it will be enabled on all switches for all VLANs. By default, in our switches, VLAN 1 will be happen. Okay, a root bridge is elected based on its bridge ID. Okay, with the help of bridge ID only, root bridge will be elected. How it will be happen? Root bridge are based on priority. DP is equals to P, priority plus M, MAC address. Priority plus MAC address. And priority is 16-bit 16-bit bridge priority is happen. That is nothing but 32768. The number, max number is this much, and whichever least priority is will be best one here. Whichever having least priority, that will be elected as a root bridge. Apart from that, then if priority is matched, then they will move to the MAC address. The MAC address, I think you know, that is 48-bit MAC address. I'll show you in lab. The default priority is 32768 and the lowest priority wins. If there is a tie in priority, then lowest MAC address is used as the tiebreaker. Whichever the MAC address is, every device having unique MAC address. Every device having unique MAC address. With the help of MAC address, if priority tie, then it will be moved to the MAC address. If I want the root bridge, whichever high-end configuration switch, means this is the 4K series switch is there, 4000, and these all are the 2K series. We'll use in our network topology. Basically how we'll use the core, the distribution switches. These all are the high-end configuration switches, and apart from that, the access switches, whichever basic switches will be to take, because cost will be happen. Thus, this access switches, less price will be happen. So we'll connect likewise. These all are different floor. These all are different floor. Understood? So we having these all are access switch again. Access switches. These all are the distribution switches. We'll take likewise. These distribution switches, if I want to make it as a root bridge, then I will reduce the priority. If I'll reduce the priority, the election won't happen, because this high-end switches only I need a master switch. We'll do likewise only in real time. Understood? Any questions? Guys, any questions? Good. Fine. The election criteria will be happen with the help of root bridge. The root bridge is the master switch. Now move to the next, root port. How it will be identify the root port. For your reference, I'm giving you one more diagram here. It is diagram. Fine. Take this diagram here. See, as I mentioned, priority, I'll reduce the priority. I need a root switch. That is the reason. And check the MAC address also. MAC address 0000111. This is a less MAC address. Whichever the least MAC address, that will be elected. Then I change the MAC address also. Understood? And these are the non-root switches, non-root bridge. Prepare your notes yourself, because it will be content whichever I am giving, it is good. Pause the recording and write this content. And root port. The root port of each switch has the lowest root path cost to the get the root bridge, whichever having cost. By default in our Ethernet, cost is like, I'll give you that note. Ethernet cost is like 100 Mbps. Ethernet cost, and this cost vary on different STP, PVSTP, RSTP. It will be vary based on, we have a different versions, STP, CST. It will be vary. This is a STP. For STP, gigabit is there, the cost is 2. 1 gigabit port cost is 4. And it's a fast Ethernet, 100 Mbps cost is 19. And we'll move to the Ethernet cost is 100. Just go right here, this cost only. Again, this will be vary on different cost. We'll discuss later. Now this will be different. Different cables having different costs. We are using fast Ethernet also, F0 by 0. I told you, right? That is the cost is 19 fast Ethernet. And Ethernet cost is, it's 100. And 1 gig cost is, gigabit port cost is gig 0 by 0. Likewise, the cost is 4. And 10 gigabit port is there, 10 gig cost is connectivity, whichever we are using, that cost is like 2. They won't change these values. Even though if you want change, we can with the help of configurations. And each switch can only have 1 root port. As I mentioned, each switch have only 1 root port. Earlier I mentioned, right? Here only 1 root port is there, not 2, 3. It will be happen. Only 1 root port. The root bridge cannot have a root port, as the purpose of the root port is the point to the root bridge. It will be point to the opposite to RP will be happen. Root port will be happen. Opposite to switch. Here it will be opposite to root port. We have a designated port only. With the help of designated port, a BPDU will be transferred. BPDU message will be originated. Path cost is a cumulative cost to the root bridge based on the bandwidth of the link. The higher the bandwidth, the lower the path cost. As I mentioned, whichever the path cost is less, that will be elected as a root port, RP. I'll show you one more in one more diagram. Here 1 gig port is their cost is 4. 1 gig port is their cost is 4. And 1 gig post is cost is 4. And there I took only 1 Gbps. These are 1 gigabit ports. The cost is 4. If I want to reach, this is our road bridge. These all are the RP and RP and road port. If I want to reach the destination likewise to road bridge, then 4 plus 4, 8. Cost is 8. If I want to reach here to here, then cost is 4 plus 4, 8. If I want to reach from here to here, this port 2, if end user is there, if we want to reach this connectivity likewise, then 4 plus 4 plus 4, 12. Then here I want to go. In these 2 ports only, one block port will be happen because of cost. That is the designated port, and one is the alternate port. Alternate is nothing but a blocking port. Blocking B. Based on the cost, it will be elect route port. It will be opposite to whichever our route bridge is there. It will be opposite to the route bridge. How will configure if I want to change any cost with the help of this command? Just I want to move interface mode, then spanning tree VLAN, whichever I should have to take VLAN, then I just cost whichever you required if you want to change with the help of this command. Any doubts? Anyone having doubts?
No, sir.
Root port, good. Now move to the designated port, blocking port. Designated port or blocking port, how it will be elect. Identified designated port. A single designated port is identified for each network segment. A single designated port will be happen in each LAN side. This port is responsible for forwarding BPDUs frames to the segment. In this segment, the BPDUs will be forward and receive. If 2 ports are eligible to become the designated port, then there is a loop. See, if here also designated port and here also designated port, here also DP, and here also if DP is there, then loop will be occur. That is the reason we opposite to DP, we have a blocking port. Opposite to DP, you can remember it like DP. Opposite to DP, we having a BP. Fine. One of port will be placed in blocking state. Eliminate the loop. Yes, good. Just now explained. The designated port is determined by the lowest cumulative path cost leading the route bridge. Whichever the DP is there, it will be originate the traffic. A port can never be both a designated port and route port. At one port only we have like designated port Otherwise, root port. At one port, it won't act as like both ports. Only in a net topology, we have one port, that is other root port, either DP, other blocking ports. We have three types of ports only here, which are the RP, DP, and BP, blocking port. Port on the root bridge are never placed in a blocking state. Root bridge are in your network topology, one root bridge is that bridge won't have blocking ports. Those two ports of switches will automatically become designated port, because designated port only send the frames. That is the reason. In network topology, in LAN side, if you have one root bridge, it won't have any any blocking ports. Apart from that, any non-designated port, we call it as again blocking port only. Non-designated port. When I say non-designated port, means it's blocking port only. And this root bridge having only DPs, designated ports only. This root bridge won't have root ports also and blocking ports also, because of this switch only responsibility for the sending frames and originating BPDUs. Every network segment must have one designated port. Every network segment must have one designated port, regardless if root port already exists on that segment. Understood? If every segment, one RP, one DP will be happen. One RP, this opposite to DP. This is a DP. This is DP. One also DP. And opposite to RP, here also DP. And this switch won't have again here RP, root port. Only one port is there, that is root port. Apart from that, if these are all having either blocking port, either DP, based on election criteria. Not much more DPs also.
I just got a question.
Yeah, I got your question.
Blocking ports for the entire loop, it may be one or it could be many.
Yes, that only I confused. Sorry. See, thank you. See, here one DP is there and one blocking port is there. Understood? If one more port is there,
Either DP or root port.
Sorry, these all are blocking only. Apart from that, one DP is there, and opposite to DP, blocking only happen. Block port only.
Okay.
Otherwise, again the loop will be originated, right? If here also DP, here also root port is there, again DP will be originate some traffic, then RP will send to again this switch. Again loop will be hacker. We have, even though we have a ether channel, there will discuss ether channel, how we can use multiple links. But here we just you assume like one block, if DP is there, opposite to DP, one blocking port only. That port is non-designated port only. Clear, Ajay?
Yes, sir.
Fine. Thank you for confirmation. Good. Anyone having any question up to here? This is your diagram of blocking port. Check here. Root switch is there. The priority is 100 and MAC address is this one. Because based on priority MAC address, it is elected as a root bridge, and root bridge having only designated ports, DP, having DP and DP. You cannot see here RP. No, RP. And blocking port also. Blocking port in alternate likewise, alternate ports. If this port went down, then it will become up likewise. You cannot see like here. Now move to next switch. How the election will be happen? See here, cost, based on cost, 8 and 8. These two ports are like root ports, not a blocking port based on cost. Now move to the why it will be went down, why not designated port, why it will be. There we have a, it will be check interface priority plus whichever interface is there, less interface, that will be elected as a designated port, whichever the less port. If here 23 is there, it will be checked, not this one, it will be checked like opposite to these ports. It will be checked like opposite to these ports. Then it will be elected as like blocking port. The port having MAC address different. This MAC address is 666 and this MAC address is 00 after 666. Next bit, the less MAC address is based on MAC address also. It will be elected as a, this one is a designated port based on MAC address also. It will be checked. After then, if we have multiple path, then it will be select as a root port. Actually root port having this a priority. Apart from that, if we have multiple port, then it will be select like 22. If this port is like F0 by 0 something, F0 by 22 likewise. If this port is F0 by 21, then it will be checked whichever the least port, then it will be give a priority of first priority on that port only. It will be moved to the MAC address. After then it will be moved to the port priority. I'll discuss these things also. Up to here any queries? Up to here.
No.
Designated port. What we discuss, same notes. Yeah. These are the root port. Please go through whichever I am giving content. To break tire. If there is a tie in priority, the lowest MAC address is used as the tiebreaker. Lowest, if the bridges ID having same, then tiebreaker, then it will be moved to the whichever lowest MAC address. This is the lowest MAC address. That is why it is elected. Any port not elected as a root or designated port will placed in a blocking state. Understood. If any port is not elected root port or designated port, it's by default it is blocking only. Any notes still up to here?
No, sir. All good.
Then what is a port ID? Discuss port ID. Just I have given some brief about port ID. When electing root and designated port, electing root port and designated port, it is possible to have tie both path cost and bridge IDs. If the ports having both elected as, that is that bridge ID. Like we have like is used to final tiebreaker and a consist of the two components. If see everything happen, designated port and root port, everything happen. If that is not elected, some blocking port only happen here. How it will be elected? The same thing here. If root port is there and designated port also elected, but how it will be elected as a blocking port only. Here see, for example, here you have to reach the cost is for this destination 8 only, and here also cost is 8 only. Then this port to this port 12 only, and this port to this port also 12 only. Understood? This port to this port only. Why it will be went to the blocking port only? Why it went to the blocking port only? See, I'm telling you why I'm explaining this much, because interviewers will give this kind of topology. Then they will explain the STP, full STP. They'll tell like this is the your root bridge, and opposite to root bridge, which ports are available and which port will be moved to the blocking port and why. Definitely they'll ask. Scenario based question, this one is that. So why it went to blocking port? Port ID is used to final tiebreaker and consists of two components. And once the everything happen, the designated port and root port, everything happen. Then if the port is remaining is there, how it will be elect the blocking. 4-bit priority and 12-bit port number reserved, and those I mentioned here. 128 is the priority and 4-bit is the whichever we are using interface port number. It will be selected based on that. By default, the port priority of interfaces is 128. I'll show you in lab this 128, what we call it as lower priority preferred. If there is a tie priority, the lowest port number is preferred. Okay, whichever we can change up to this 32-bit also. Max is 255. We can increase or decrease also, whichever the lowest, that will be elected as a designated port. After then, this if 128 and 128 both and basic 128 priority only happen this side also by default. Here also 128, and this port also having by default priority is 128. Then it will be moved to the port priority. Then port is nothing but again F0 by something I explained, 0 by 1 if there, then 1 it will take. If F0 by something 2 is there, no, opposite port, this port it will be select, not this port, this port. If 128 plus dot 1, if port is F0 by 0, if 128 2 something. It will elect likewise. How if I want to change the port priority with the help of 128 to, I can make it as a 132, sorry, 32 something. Apart from this also, I can change the priority with the help of this command, whichever VLAN is required. Port ID is the least tiebreaker. STP will consider STP determined route and designated port using the following criteria in order. That lowest path cost, whatever we discussed, that same thing, and lowest bridge ID and lowest sender port ID. The lowest bridge ID is always used to determine the route port. Anyone having any doubts up to here? And I'll give you some brief introduction about how many versions are available in STP. In different versions, we have STP. There are three flavors of the original. We'll call it as an STP, and the IEEE standard is 802.1D. 802.1D. This is the IEEE standard. IEEE standard. And there we have an STP version, CST, PVST, and PVST plus. Common spanning tree and per VLAN spanning tree and per VLAN spanning tree plus. And CST utilizes single STP instance for all VLANs and is sometimes referred to as mono spanning tree. All CST BPDUs are sent over the native VLAN on a trunk port, and those are untagged. Whichever untagged traffic is there, with the help of CST, it will be work. PVST implies a separate STP instance for each VLAN. Improved flexibility and performance. PVST required trunk port to use ISL encapsulation. PVST and CST are not compatible for this. There we have only if you want to trunk port, there we have this kind of criteria will happen. Encapsulation will be happen, right? And it won't support likewise. But in PVST, it will be support both ISL and PVST plus. It will be by default, it will be enabled in some Cisco switches, PVST plus only. It will be support like ISL and .1Q. Sometimes some switches it will support PVST in encapsulation or not. These are the versions. We have different version in CCNA, and this is the sufficient for you knowledge for version part. If you want, we'll discuss also. Okay, up to here, anyone having any doubts?
No.
Okay. And election criteria will be discussed on PVST, CST, and multi-VLAN also. MST also we have the version. Fine. If you guys okay, we'll see the basic lab. We'll discuss the basic lab.
Okay.
Good. And we have some states also here. The blocking state. Go through this up to states, STP states. With the help of states only, the election will be happen. It will be moved to the blocking state. Here blocking state and listening state and learning state and forwarding state. A blocking port will not forward frames or learn MAC addresses, which are because of blocking state will happen. A blocking port will still listen BPDU from other switches to learn about changes to the switches. If any topology change is there, then it will be learned from that with the help of blocking port, with the help of BPDU packets. It will be listen the BPDU packets if the port is in blocking state. Like you have two switches here, one switch and other switch, they are both communicated. This is your root bridge is there, this one root bridge, then this root bridge having designated port DP, both are DPs, and one will be RP, other one be alternate blocking port. Then because it will be down, then but this blocking port still it will be listen the BPDU packets, because if this port went down, then it will be automatically come up. That is the reason it will be listen the BPDUs. In BPDU, what content will be sent? Port numbers, port priority, and whichever the switch information, and whichever the frames originated, and IP addresses. This all information will be sent. It will listen. This all the frame packets. Now move to the licensing. Elected of root and designated port will happen in the state. Root and designated port happen in the state. A listening port will not forward frames or learn MAC addresses. It will be not forward any frames. It won't forward. And a listening port will send and listen BPDUs. And it will be send and listen the BPDU packets because of any topology changes. To participate in the election of the root bridge, root port, and the designated port. If any changes occur in topology changes occur, then it will be moved to the port changes required. It will be listen the BPDU packets, but it won't forward the frames information. It won't forward in listening state. It will be listen only. In learning state, we have learning state. If a listening port is elected as a root or designated port, it will transition to the learning state. Okay, if the listening port elected as a root or designated port, once the port is elected as a root port, in this root port RP, sorry, these are the designated port, and this one the RP. It will be learning as a state. It will move to the learning state. That is the learning state. It will be struck. A learning port will continue to send and listen the BPDUs. It will be continuously send the BPDUs. A learning port will begin to add MAC addresses to the CAM table, and it will be add the CAM table also. In switches, CAM table viewer, content address memory, that is the table. It switches maintain the CAM table. It will be happen in learning state only. In learning port cannot forward frames quite yet. It will be won't forward the it won't forward frames. In forwarding port only it will be happen like designate. A forwarding port is fully functional. It will send and listen for BPDUs, learn MAC addresses and forward frames. Okay, root and designated ports will eventually transit to the forwarding state. Whichever our designated port and root ports are there, those are the forwarding state will be happen. And finally, one is a disable port. It is used to block the port manually. Disable port. One more we having a disable port. It is used to block the traffic. Okay. Till up to here, any doubts? Basic lab. See, I'm taking here 2 switches only. See, I haven't configured anything. The port states are changes. Check. It will be, the time will be happen 30 seconds. And every 2 seconds, BPDU frames will be originated. And it will be listening, learning, it will be time will be happen. Show spanning tree. See, now both are learning state. Learning and alternate port. Learning and blocking. In 30 seconds, the port election will be happen. It will be take time. Okay, the port is like so spanning tree. With this command, you can check it. And here root ID is whichever this information is that root bridge, whichever the root bridge is there, the root ID is this information. And this is that whichever we are checking the information, like this switch information is this one. This is that roots bridge, and this one is that whichever the bridge ID we are checking. And this MAC address is like root switch. And this is a cost because I am using here fast Ethernet. That is the reason. Cost is 90 and port is fast Ethernet. The timer here is hello timer. Every 2 seconds, it will be send the BPDU packets. And if the port went on, it will be max, it will be sent up to wait up to max age is 20 second. And if the delay like forwarding, it's 15 second. And these are the switch details. This is the MAC address. Sorry, this switch, whichever we are switch 0, that switch 10, the details is MAC address of the switch. If you want to verify, how will we show version? With this command, you can verify the MAC address. Last four digit are CA43. 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 You can verify these details. And now move to the spanning tree here. And these ports are, one is, this switch is non-root bridge. That is the reason we have a alternate blocking port. Status is blocking port and forwarding the information. And forwarding means it will be carry the BPDU packets and it will be send the packets. It will be receive the packets. Forwarding state. And cost is 19 because of fast Ethernet. And our priority of route, let's see, 128, it's by default, whichever we having 2 ports, the fast Ethernet 0/1, that is the reason it is elected as a root port because of lowest priority. And every switch having only one port, like it won't have like 2, 3, 1, 1, 1, 1. It won't happen likewise. It won't tie likewise. The final election will be happen here only. It won't tie. And finally, we have a blocking port because of that port priorities. Type is point-to-point connectivity. Understood. That is the reason this port is went on. And if you want to check root bridge, check here how it will be happen. This one is the root bridge. Enable. Why it is elected as a root bridge? Why it is elected as a root bridge? First, show version will verify the MAC details. Here, MAC details of this switch is first 4 characters 0004. And this switch having MAC details is show version. See, will be based on the MAC details list. Now move to the check how it is show spanning tree. Same information is because of this bridge is a route. This bridge is a route. This switch is a route. Understood? These 2 ports are designated ports. See, and these ports are forwarding state. Understood? Till you have any queries? This is a basic thing. Otherwise, we'll discuss tomorrow this lab and how election will be happen. Everything we'll discuss tomorrow. Till do you have any queries? Guys, anyone having any queries? Please go through what still we discussed. I'll upload this video today. Just go through. If you have any queries, just ask. Tomorrow we'll discuss. And we have lab tomorrow.